Welcome back. We are on to 1.4 negation. So some of these lessons here, especially as things get a little bit more complicated, we'll talk a little bit about the section before jumping into the exercises. So that's what we'll do here. So the concept of negation is something that you may or may not have gone over prior to this course. I know you've done subtraction and I know you've done negative numbers, but the concept of negation, possibly not. So here's the idea. So you have -2, it's right here on the number line, and you have +2, which is right here on the number line. You can see that -2 is this distance from 0, and +2 is actually the same exact distance from 0. So what happens if you add those two together? If you do -2 plus 2? Well, if you've done anything with negative numbers or subtraction, you know that 2 minus 2 or -2 plus 2 is going to be 0. And this should be pretty clear, because if you're at -2 and then you add 2, you get back to 0. So that makes sense. But we can kind of think of that as canceling each other out. So the negation of 2 would be -2. That's how you make it 0. And we know that that works for any x. So if you're at 6, then if you subtract 6 from it, then you get back to 0. If you're at -6, you have to add 6 to it to get back to 0. So we can say that -x plus x is going to be 0. All right, so that's the basic idea of negation. So let's go over some of these exercises here. So negation of 4 is -4, negation of 3 is -3, and so on. So A, consider where the numbers at the ends of the facts above are on the number line. After the first number, how is each number related to the number above it? And then based on the pattern, let's fill in the blanks here. So go ahead and give this a shot, and then I'll continue. All right, so for part A, consider where the numbers are on the number line. So the first one, negation of 4. So 4 is right here on the number line. -4 is over here, and they're equal distance from 0. So they're on the opposite side of 0, as we can see there. How does each number relate to the next one? So here we're going from 4 to 3 and 3 to 2. So we're going down 1 for each step. And on this side, we're going up 1. So we'll do +1 from -4 to -3 to -2 to -1, and so on. So if we continue this pattern, we go down 1 to 0. We should go up 1 to 0, right? We have 0 here. Negation of 0 is -0, 0. All right, so let's think about this for a second. So we know a couple of facts here. So, so we know that right here, -x plus x equals 0, right? So we know that -0 plus 0 should be 0, because that's what negation is. That's what we said negation is. A negative something plus the positive something is going to equal 0. So we know that this is true, right? But we also know that adding 0 to something doesn't change it. If we remember, I don't know how far back in the slides it is, if I can find it quickly. Probably not, but, oh yeah, it was back in addition. Anyway, it's not that important. Okay, I'm committed now. Now I've got to find it. There it is. A plus 0 is A. Right? So, oh goodness. Okay. So what was that? It was A plus 0 equals A. All right, so if you add 0 to something, it doesn't change it. So we know that this is true because of negation. But we also know that if you add 0 to something, it doesn't change it. So -0 plus 0 should be -0, right? But how can -0 plus 0, which is what it is here, and it's the same exact thing here, how can it equal both 0 and -0? The only way that that can be true is that -0 is equal to 0. So we can conclude that -0 and 0 are the same thing. So if we follow this pattern, say, this is, we got positive numbers on this side, negative numbers on this side. If you want to say negation of 0 is -0, people don't generally talk about -0. So negation of 0 is just 0. But we also know that -0 and 0 are the same thing. So saying -0 here wouldn't technically be wrong, but again, people don't usually talk about -0. So Either one will be technically correct, but I would say negation of 0 is 0. Anyways, enough about 0. Moving on. Negation of -1 now. All right, so we could probably be pretty confident in saying that the negation of -1 would be 1, but let's just show some stuff real quick. So let's see, we know that the definition of negation that we used was negative x plus x equals 0, right? And that's true for all values of x. And we also know they gave us this one here. A negation of 1 is -1. So we know that -1 plus 1 equals 0. So we know that these two things are true. So if we plug in -1 for our x, so if we say x equals -1, and plug that into our formula right here. So we have -1, right? And then we have plus our x, which is -1. Then that should equal 0. All right, and then with our commutative property, we know we can switch the order of these. So let's go ahead and do that just so I can show something real quick. So we have -1 plus -1. Yeah, this looks a little bit messy, but we're getting somewhere here. All right, so now that we have that, now this is closer to matching this right here, right? We have the -1 here and the -1 here. We have plus, and this one here is the only difference. This one here is -1, and this one here is just +1, right? And they both equal 0. So if this term is the same, if this -1 term is the same, and our result is the same, then we can conclude that -1 equals 1, because these have to be the same. If everything else is the same, then those two have to be the same. So if -1 is equal to 1, then we can say that back to our original negation here. Let's go ahead and erase some of this. Get this one here, and this one here, and this one here. It's like a fun little game now. All right, so back to our formula here. So our negative x, so -1, plus -1, we know has to equal 0, because that's our rule of negation. We now know that -1 is just 1. So 1 plus -1 is going to equal to 0. So we also know that 1 minus 1 is 0. So that must mean that if you add a negative, then you get 0, which we kind of already knew. We've done that before for some of these other ones, but just wanted to note that if you see a plus, a negative, that's actually what subtraction is. And we'll talk about that a little bit in the next section, is that that's how we're going to redefine subtraction, is adding the negation. All right, so yeah, again, we know that -1 is going to equal 1. Does that work for everything? So can we say that negative x is x? So in order to prove that for all x's, because we saw that it worked for that one, for -1, that seemed to work. Everything worked out okay. So let's go ahead and play around with this expression right here. So we know that x plus -x should be 0, right? And we know that -x plus -x should also be 0. Yeah, so let's go ahead and just write that out. So delete all the annotations there. All right, so again, this x plus -x, that's our definition of negation right there. So you know that that is 0. You know that this is 0. And let's go ahead and bring this along for the ride. Plus -x. And again, we're trying to prove that -x is equal to x, but we'll get there. So we know that this is going to equal, well, if you add 0 to anything, you just get the same thing back. So that's going to equal -x, right? So So that's cool. So we know that. So that's one fact that we know. So we'll put a box around that. But let's do this a bit of a different way. Instead of doing this part first and saying that that's negation, well, look at this part. This is also negation. We have a negative x plus the negative x. Remember, commutative property, we can change the order of that. So we have a negative of something and then the something. That's going to be the negation. So we can also say that this part is 0. So we can also say that x plus 0 is equal to x. If you add 0 to something, it doesn't change it. So we can say that this statement is also true. So if this equation here, depending on how we do it, if we can get the answer of x and also negative x for the same expression, that means that x has to equal negative x. So that does indeed work. Check. It does work for all x's that negative x will always be equal to x. All right, so that was cool. So check out this warning right here. Even though negative x is sometimes spoken as negative x, it does not have to be a negative number. So when if you talk about negative x, but x is equal to -1, then this value here is actually going to be a positive value, because -1 is going to be a positive value. So when you hear negative x, it doesn't always necessarily mean it's going to end up being a negative number. So just watch out for that. All right, so stick the multiplication facts below. We know that 4 times 3 is 12, 3 times 3 is 9, 2 times 3 is 6. We did something similar to this in the last section. Consider where the numbers at the ends of the facts above are on the number line. After the first number, how is each number related to the next number? And based on the pattern, what would the next number be? All right, so we can see that it's going down by 3 each time, which you know on the left side here. First one here is going to be 4 3s, and then 3 3s and 2 3s. So there's 1 less 3 each time, which is why you get 3 less each time. 12 to 9 is -3, -3, -3, -3. So if you're at 0, follow the pattern, you get -3 right here. Okay, so multiplying by -1 appears to negate the number. If you had 3 and you multiply by -1 and you get -3, that looks like the negation of 3. So is it always true that if you multiply by -1, you get the negation of the number for any x? Let's prove it. All right, so first let's replace x. This is going to be the same thing as 1x, right? Because we already showed before that if you multiply x times 1 times any number, you just get the number back. So we know that this is true. 1x is going to equal x, so that's fine. And we know that the negation of 1 is going to be -1. So we know that -1 times x plus 1 times x is going to equal 0. And now we can reverse the distributive property to bring this x out. So now we have x times -1 plus 1 equals 0. And we know that -1 plus 1, that's negation. So then that gives us x times 0 equals 0. And now we can prove that this one right here was true because we know that this is true. Multiplying by 0 would always give you 0. We've talked about that before. So it holds true that -1 plus x is 0. So this worked out to be true, which means we have proven that -1 times x is going to be -x. I don't know if that was easy to follow or not. But to put it a little bit more clearly, all we did here was use rules that we already know about negation to prove that that -1 times x is going to equal -x. And just to do a really quick recap, hopefully this is a little more clear, we would know that it's true because the negation of x is -x, or -x plus x is equal to 0. All right, so if -x is equal to -1 times x, then this should be true. And we just proved that that is in fact true. So we can conclude that -1 times x is going to always be -x. Again, I don't know if that was super clear or not. I apologize if it wasn't, but the whole point is that yes, multiplying by -1 is going to give you the negation of that number. All right, well, moving on. Using the fact that -x is equal to -1 times x, explain why this is true. Go ahead and see if you can come up with a good explanation for that one. All right, so multiplying by -1 is the same as negation. So we know that -1 times 2 is going to be -2. We know that -2 times 3 is going to be the same thing as this. So again, so we're just replacing this -2. So that's from this left side of the equation here. We're going to replace that -2 with -1 times 2. Because we know that those are the same thing, right? -1 times 2 and -2 are going to be the same thing. And then we can use the associative property to rearrange this. So then we can kind of just change this grouping around to make it look like this. -1 times 2 times 3. We know 2 times 3 is going to be 6. We know 6 times -1 is going to be the negation of 6, so that's going to be -6. So if we have it like this, oh, okay. I was trying to remember what this comment was. So, all right. So we have a -1 times 2 times 3. So if you remember, if we had something like -1 times 2 plus 3, you might remember distributing. So you have something outside of the parentheses here, and there's multiplication right here. You can multiply times there and times there. So you might be tempted to do that right here too. It's like, oh, there's something in parentheses. There's multiplication outside of that parentheses. Do we distribute there? No, do not distribute when you're doing multiplication inside the parentheses. So if you're multiplying inside the parentheses, you cannot distribute. That's only if you're adding or subtracting. Or really, we'll just talk about addition from here on out. We won't really talk much about subtraction. But the idea also works for subtraction. But do not try to distribute if it is like that. Let's do that. All right. So we can say that this part is true here. So -x times y, we're going to end up being able to extract that negative to the outside like we did here, like we did right here. And it's going to sort of look like that. We can kind of pull that negative to the outside, and it's going to end up being a negative number. So a negative times a positive is a negative, and a positive times a negative is also negative. So this would be the same thing if it was +2 times -3. We could ultimately extract that -1 outside of the equation, and then it would also be a negative number. So the whole point of this is negative times a positive will also always be a negative. Just like a positive times a negative will always be a negative. And we'll see a little bit later that a negative times a negative is actually a positive. And of course, we know that a positive times a positive is always a positive. 2 times 3, for example, is going to be +6. But this kind of just is a rough proof to show why a negative times a positive will always be a negative. All right, here's what we were just talking about, that -2 times -3 show y that is equal to 2 times 3. So see if you can do what we just did over here on this slide to prove that a negative times a positive is going to be a negative, which is by converting the the negative to a -1 times the positive, and then trying to rearrange and regroup things using the associative property. Try to do this one in the same way. See if you can prove why a negative times a negative is a positive. All right, let's give this a shot. So let's do the same thing we did before. So we'll pull out the -1. So we'll say that -2 is the same thing as -1 times 2, and -3 is the same thing as -1 times 3. So we cannot factor this, but we can regroup. And the reason why we can't factor this out is because we're not adding anything. If it was something like -1 times 2 plus -1 times 3, then we could extract out the -1 because we have this addition right here. We don't have that here, so we cannot factor. It's another thing that you need to watch out for. So we can't factor that out, but we can regroup it with the associative property. So we can just rearrange this and put these -1s together. So we can put these -1s together, and we can put the 2 times 3 together. So we know that 2 times 3 is going to be 6. We know that -1 times -1 is the same thing as negative. We know that that cancels out to be a positive. We did that before. Negation of negation cancels each other out. That's important. And remember that negative x is x, same thing as negative 2 times 3. So negative, I think I missed a parenthesis right there. That's okay. Negative 2 times 3 would be equal to 2 times 3, which is what we have right there. So that does become a positive number. And it's because of this part right here. This whole negation of the negation right here becomes a positive. So then whatever we left over here is going to be positive because we left only positive numbers here. So -x times -y is going to be xy. All right, using the fact that -x is equal to -1 times x, explain why this is true. So this is the same thing that we had a couple problems ago, except in reverse. Okay, so negation is the same as multiplying by -1. So -4 plus 5, which is what we have right here, is the same thing as saying -1 times 4 plus 5. And the last couple of problems I've been saying when you can't distribute, but this is one where we have addition, so we can distribute. So we would distribute this -1 across that. So then we get -1 times 4 and -1 times 5 right here. Multiply that out. -1 times 4 is -4, and -1 times 5 is -5. So that's exactly what we have right there. And if we add those together, then we get -9. So negation does distribute. It would also distribute the same in longer sums. It doesn't have to be only 2 terms. It would distribute here in the same way. So -x, -y, -z. All right, and that's it for 1.4. So go ahead and do these exercises at the end of this section, and we'll see you next time for 1.5.